Okay, hello everybody and welcome back to your Saturday, October 7th video series. This is the second of 3 videos. To be perfectly honest, I may need to publish the third video later this evening or tomorrow morning even. In any case, this continues with the technical parametric and performance modeling series. Let's dive into the reminders of the 3 pieces of tech, focusing on generators and evaluators today. And exclusively thinking more here in the landscape modeling for LandKit Pro. So LandKit includes a number of different kits. Today's focus is on plant kit. So we're going to take a look at, what is in the kit. We'll take a slightly compressed or shortened view because, the kit is big, and I'm not going to lie that it's probably too big to go over everything in detail. So what I'm going to present in this video is a shortened version of some key elements, and then I can point you to some other resources to take things further if you want. I would say the most beneficial element coming out of PlantKit is the generators. But there's ways of combining things with other aspects of the kit and other tools that will make it amenable and useful to your evaluators. And just some reminders of those learning resources and a walkthrough of the first file, and then just telling you about the other files. So super high level reminder, LandKit Pro is comprised of the different kits. We went over Topo Kit and Water Kit, and today we're going over Plant Kit. You're welcome to explore Paving Kit on your own because it's a bit more straightforward and you can use it for any of the other ones. So today we're focusing here, which not surprise, it's about managing, referencing, allocating, analyzing, and documenting plants that will illustration. Just pause, hold on one second. Okay, sorry about that. My pointer focus has been glitching out and I just wanted to make sure that it's ready to use today. So sorry for the delay there. Yeah, so channel your inner Bulbasaur. I'm channeling mine with the hat here. It's gonna be fun. Hold on, because there's lots of elements to take into consideration. So let's take it one step at a time. When you look at Plant Kit, remember it's in the ribbon tab. It has the green box pointing downward. It can be a little overwhelming because there's lots of components to potentially use, and we're not going to use them all. I'm not going to for sure use them all or even introduce them all, nor do I think all of them are super relevant to the work that we're doing. Some key ones out of the subcategories to draw your attention to: the Create subtab. Like the Water Kit, it's important to know that you need to make an E file, an environment database to collect a bunch of different aspects that might come together. And you need to define an area to put your plants on. These are the 2 most important things out of the collection of 4. So, I would say you can even avoid the other ones. You probably will not need them, at least not at the beginning. Now, that gets you started. Ultimately, what you want to do is you want to lay out plants. So the third ribbon tab, I think, is probably, if we're thinking about that reverse engineering logic of like, I want to put down some plants, I want to put down some circles, I want to put down some geometry and make some stuff. This is actually where I typically start. I'm like, I want to pack some plants or fill an area with plants and just see what it's asking for. So you'll notice that when you look at pack plants or filling them with a pattern, they kind of ask for similar things. They will almost always ask for A, which is the area, which you can get here at the beginning. And area needs E. So you'll see it's like, tell me what environmental conditions I should take into consideration. We'll look at this in more detail with the sample, but I just want to let you see that like the packing of the plants, it's pretty easy to reverse engineer things by kind of following these inputs as prompts. You can hover over them, see what they ask, try to reverse engineer it. It's not too difficult to see these. But out of the layout, these would be the ones that I would suggest starting with first. There may be some other ones that you can leverage, but these would be the most important ones. Analysis. Basically, what analysis does is it says, give me an environmental database. I will add some complexity to it and give you a new environmental database as an output. So I could add images that would govern where my plants would go. I could add elevation or slope. I could add sun exposure. Um, there's a lot. There's a lot in here. I'm not going to go over everything, but I will say that these are up to you. There is no right or wrong. There is no start with this one first and then the next one. These are dealer's choice. It's your element to explore. The data ribbon tab is pretty interesting. Probably the most important one is this one called Create Plants from CSV Data. We will take a look at this one in a lot of detail because this one basically allows you to create your own list of plants that you would consider important for your site. I will also say that this process can allow you to hack PlantKit to not just put down plants, but you could put down other things like program bubbles. You could put down solar collectors, wind turbines. It's doing it in an abstract way. And so you would need to correlate the results afterwards. But because it allows you to reference a list of things like a .csv file, it gives you a lot of control here. So we can talk about that. And I think Tuesday, I'm going to make it almost all just review of PlantKit because it's pretty rich. And then finally is draw. Basically, draw for me the plants. These would be the two. There's a lot in here, but the most important ones are out of laying out the plants. You see it gives you A and P, the area, and the P is plants. Basically, these plants draw components are like, give me P or P and A, and I will draw for you the actual plants that you algorithmically put down. So let's continue on here. Again, layout is perhaps one of the most interesting features here. The way that the packing of the plants works, because you can also just put down plants with just straight up on a pattern, and that's fine. But the real special sauce of this component and of PlantKit really in general is you guys have been seeing this now where you're like, I want to draw some circles, but they overlap. So how do I get them to respect their boundaries so that they compress in? And this technique is what's called bin packing. In computer science and in applied computer science, it is a challenge that a lot of people have had over the years, which is you've experienced this yourselves. I have a set of things. How would these set of things fit together? Now, there is a caution to this, which is bin packing does not always create the same result. There is a high degree of not randomness, but where a first plant goes, or a circle in this case, a bin object goes, where it starts, and how the other elements fit around it makes a huge difference. This is 6 graphical representations of the same set of elements. So the same quantities and sizes of circles. Here's a big one, here's that big one, here's that big one, here's that big one. And you can see that it creates different results based on where it starts and where the user defines different parameters. So please take this with a high degree of consideration. Bin packing is as much of a science in terms of I will get you a solution based on what you tell me, as it is an art in the sense that it's up to you to define special parameters to get to what you want as a designer. I cannot stress this point enough. You really need to be mindful of how the algorithm will pack things in. And even with sometimes the same exact parameters, there will be a degree of variation that occurs. And that is okay. In the world of optimization, there will be a little bit of discontinuity between your parameters and your solution space, a little bit of discontinuity, but not enough to invalidate doing multi-objective optimization with a genetic algorithm. There's enough that it makes it a little bit quirky, but that quirkiness, I think, is what's nice. And there, again, it does not invalidate our efforts with Wallasey or Galapagos. The second thing to call your attention to that you probably are not maybe used to doing inside of Grasshopper is pulling in data. So the data create plants from CSV is pretty interesting. We will take a look at some .csv, which stands for comma separated values, .csv. Think of it as an Excel sheet that is down to its dumbest form. Grasshopper cannot read Excel sheets, but it can read .csv files, a simpler, dumber form that just looks at values that are by columns and rows separated by a comma in long form text. And you can take a file like this that has names and heights and spreads and parameters like sun exposure or water, and you can use it for your own purposes. Now, we didn't talk about lands design all that much in this course yet, but lands design, which you all should have a license to access from Rob, was a great resource for me and for a couple of other people who use LandKit and maybe don't know that much about plants. I would say the biggest benefit of lands design is actually its plant library. It is really extensive and really great and easy to navigate and easy to get values from. So the file that we will use as a sample.csv file was made from lands design. I can show you how to do that, but for your own projects, again, this could be anything. This could be plants that maybe you already know. This could be plants that you want to bring in that are native to the site that you might have some data from. Or this could be not even plants themselves. You could literally, again, abstractly plant down program, where you could say the height of a particular program is a certain size, its spread, its diameter is a particular size. So a .csv file is like a very generic database to add in a lot of stuff. But just to let you know, lands design is there for you if you want to start building your own database of plants, which I think would be super exciting. Where to learn more? In the Discord earlier today, put down a cautionary note, which is PlantKit is pretty rich. And I'm going to cover some stuff here, but not everything that may interest you specifically. So please remember to go back to the Miro board, review where the LandKit learning resources are that I scrubbed from Campus Plus. And if I had to rank what would be useful out of these videos, the first list, which comes from the overall introduction, I ranked 5. It's really good. And then the PlantKit deep dive, that one is also really good. And it came with a presentation, a PDF presentation, which is nice. It's a bit long, so be mindful. You might not get through everything on the deep dive, but I would really start with the overarching one. Actually, maybe I'll just go here so you can see what I'm talking about. So here's our class Miro board. Again, this is me scrubbing Campus Plus and bringing everything here for you. This LandKit intro, it's 1.5 hours. It has elements of TopoKit. It has elements of PlantKit. Chapters 3, 1, 2, 3, these are really good. I gave it a rank of 5. It's really good as an overview. The deep dive is definitely super great. And number 3, the introduction, it's okay. It's maybe a good like little brief refresher of what you learned up here in chapters 3 through 3. But it's like, you would have already seen it up here. So be mindful. Okay. Let's continue on here. Speaking of the PDF, I'm going to go through a couple slides from that PDF that I think are worth highlighting. So you have probably now fully experienced this. I don't really need to drill down this point, but the conventional design process is, you draw something, you sketch it, and then you have to manually, digitally redraw it to quote unquote make it look better or do some calculations. The LandKit design process, the general computational design process, is that you get some concepts out and then you encode parameters that would control that. In this case, this squiggle can be reinterpreted a number of ways, which is exactly what we're doing, is this kind of generator process. With plants, this is for me particularly interesting because I'm not practicing planting in my day to day, and whenever I've talked to designers, landscape architect designers, they're really good at plants, but typically it's all in their head. They know plant lists, they have analysis, they have dependencies, they know what the plant looks like, they know how it can be represented as circles or blocks. They have clippings of it in Photoshop and they know how they might get put together. And that can be kind of daunting for a designer. And so the plant kit approach, which is similar to the topo kit approach, is that you feed it data, rules, and analysis. And then it helps you do placement, visualization, documentation, etc. And you can keep adding things at the beginning and customizing what you get on the outer end of it. And so as a computational process, basically, diagrammatically, it looks like this, which is that you bring in some plants. It can be a big list or a short list. If it's a long list, you could filter some things out. This may not be needed for you. You may just make a list that's specific for your project. You could apply some niche values to an area, like, hey, I want to make sure that I make some, niche values from the plant itself. Another way to filter plants, like only give me plants of a certain height or that are sunshade preference. So in the end, you bring in a plant list, either long or niched, and you get a plant list that you want to work with. And then you have your model, your topography that you start with. And maybe you want to have some analysis on top of it, like water flow or shade or proximity to other objects. And that's what gives you your environment. And the combination of plants and environments, which includes an area to put them on, helps you place the plants in the computer, and then you want to draw them at the end. So it's kind of what we're going to be doing. And that the way that it looks like in PlantKit with the specific graphical nodes is that you create that environment. Well, we're going to go back here. Let's start with plants. You want to create your plants, which can come from data, and you can add niches. And you want to make an environment and an area, so that can come from a mesh and some conditions of limitations. And then you say, here's where I want to put the plants. And then it lays it out computationally and allows you to either visualize it or export them as blocks. So a couple things to keep in mind is that the plant constraints or niches can be a lot of different things. It can be shade-based, water-based, pH-based. There are many ways to create niches that can help you filter down which plants to put where. Where you will notice if you watch the video from the LandKit team, they get a lot of their data for plants from what was called the ERA, or the Eco-Regional Revegetation Application. When you're watching their videos, it's a caution because it seems like this is super easy, and it is. You can go to this website. This was made for the Federal Highway Administration of the Department of Transportation in the US. And if you go to this website, you can click on a different state and you can see all the plants that are native to that state, and even more specifically, you can go into certain eco-regional zones, and that allows you to extract a set of native plants from that region. Unfortunately, there is not a Canadian equivalent that I am aware of yet. Maybe Rob might have some different knowledge around this. But from the land kit, plant kit perspective, keep in mind that they reference this like it's easy peasy and it's great, and it really is, but only for the US. So there's no Canadian data. And the other thing that's a bit annoying is that it's also in imperial values. So it's preset to feet and inches. You can see here height in feet. It's preset to certain language values, American spelling for certain species, things of that nature. So keep in mind that take their videos with a grain of salt. But here is some examples of how the LandKit team was able to populate these zones here with these specific plants that you can see. There's kind of like a logic here, right? Like smaller plants around the periphery, blue tall plants kind of around the edges, yellow plants much more towards the interior, and some gray plants kind of nestled around. And to get to those results, there is a series of things you can do. So again, some of this is repetitious, so apologize, but you start in this diagram, this exploded isometric, you would start down here with your topography. And based on your topography, you can then layer on different environmental analysis layers. It's your choice. You don't have to add on environmental layers. That may not be important for your work, but this is the concept that you could leverage. You could add on elevation, water, sun. You could add on only one of those if it makes sense. You could add more if you wanted. So there's environmental layers, which again, they could be sun exposure that takes into account other buildings, water flow, soil moisture, a whole number of parameters here. And then there are what's called designer layers. Designer layers are, we'll call them geometries that you make. So you could say, I want a color zone. I want plants that are only of a particular color to go in a certain area. And that the combination of these designed layers and environmental analysis layers create a final effect. So, to drill into design layers a little more, you could say they call them these things like shrub layers, color areas, clonal areas. The naming of them specifically does not matter. It matters to them personally, not universally. But you could add in something like a shrub area that's like, I drew a shape here and I only want shrubs to go there. Or I drew a certain color and I want certain plant colors to go there. Or clonal, I don't even know what clonal is. Whatever. But again, this is their logic of design intent, which could be combined with environmental layers. So the example here that they have of that same process is that they had this, this example here. So these garden planting zones, in this kind of square or plaza, and they wanted to take into account shading from these peripheral buildings on the plants itself. So in this case, they had 3 different plants based on sun exposure. So these shady, dark gray areas you can see are pulled from the analysis that they have from Ladybug. And then they have used that analysis to say, hey, plants, only the partial shade tolerant ones can go here. And here there's a very dark area from the analysis, and that's only where shade tolerant plants can go. So you will have this ability once learning your plant kit. Now you can add some additional constraints if you wish. All plants come with a little bit of self-spacing. So each plant, you can adjust its self-spacing radius. Maybe this matters, maybe it does not. It's up to you. Maybe for program packing, this may make a lot more sense to manipulate. Clustering, certain plants can do this, particularly like they only group up. They never are separated. They have to stay in a cluster. There's some co-location, like a certain big plant goes down and other ones will want to go around that particular one. So maybe program wants to combine with benches or something if it's more abstract. But in species, maybe it's one plant attracts other ones, and that's also fine. And then there is constraint mapping, which is like stay further away or closer, etc. Finally, there's things like pattern filling. So this is combining the paving kit to say, like, I made a pattern and I want plants to go inside that pattern. So the results, I mean, I'm not going to belabor this, but Plant Kit is really awesome. It's really big. It can make legends for you. It can make a blooming calendar for you. It can do so many things. You know, take it step by step as you learn on your own. And how we're going to start learning the files that I'm going to go through. Inside the FTP, you'll see under populations, not under surface. So maybe just to make this extra explicit, when you go into the FTP via WinSCP or other, you'll see under technical, there's parametric and performance modeling, and there's O2 populations. Here, there are 2 subfolders. Both of them use PlantKit. This is the only tool we're going to use to essentially make plantings happen or populations happen. We're not going to look at anything else for now. We may do some advanced topics, but this is where to start. My honest suggestion is to actually start here, PGO2. That's why I'm calling this out here, is to start there, because I made a starter file and I'm going to go through that starter file with you now. The LandKit PlantKit file on its own references the sample files from the PlantKit deep dive, and I've cleaned them up because you know, you can download the LandKit ones yourself if you want to, but be warned that they are a little messy and they do not have much annotation on them, and that may be a bit of a challenge for you. So all of the ones that come from here, I've recreated them to be Canadian specific, metric specific. and a little more didactic in terms of annotation. And then finally, you might be like, what the hell is this graphics folder? The graphics folder is not land kit. This should say lands design reference. It's those files that I pulled from lands design for the plants, if you're wondering where I got them from. Oh, we don't want to learn more about water kits. Apologies for that snagging in there. Might as well just fix this as well. Lands design reference. Okay. So let's take a look at the actual lands design example first, and then I will just quickly review the plant kit deep dive. And this presentation is no longer than this. So to start, I am going here, PG02. I'm using this Rhino file. And I'm using 01. I'm using 01A. There's only a smidgen tweak difference. It's not much. Both of these would be fine. When you open population generation land kit, plant kit, lands 01, sorry that it's so long. I'm just trying to keep it organized in my own brain. You will see this file, which just looks like a little plaza with some hills, and nothing super special here. Just some hills, some depressions, a couple hills here. There is a notes file, just helps you with the plants, telling you what it is. There's some dimensions, and you'll notice that there's a height of something here because there is some elements in the context. There's a couple buildings, and these couple of buildings are going to cast shade on the plaza topography. And so that's what really matters here. That's what's going on. So context has that. There are some design layers. They just have some regions, some curves. I will reference them, but I'm closing it up for now. I can close up. I'm going to keep topo on just for a second. And then there's plant blocks, plant lines, baked, and test. Don't worry so much about these. They are placeholders for some plant blocks that were really beautifully made by Chris Landau from LandKit. He actually made these using some generators of his own to create this wide sample set, and we will reference that sample set at another time, but that's why it's there for plant blocks. So what you need to worry about when you open the file is just this. But if you're wondering what's going on there, that's what's going on there. I also put in a person for scale reference. You're welcome to use this character as need be. It was helpful for me to understand scale when putting down my plants. So if that's the Rhino file, what does the Grasshopper file look like? So as per usual, I tell you, hey, we're using land kit, topo kit, plant kit in here. Please remember to have land kit installed if you don't already. Paneling tools was useful as it dealt with, sorry, not paneling tools, pollination tools, the ladybug tools. So make sure that you have that installed because we will do some little bit of solar analysis. And I will have to make a separate video, or maybe we'll talk about this in class, is how to read in weather data files. Don't worry too much about this, but if you are wondering where I got the weather data, it came from the Ladybug EPW map. So I will just copy this and we'll just take a little peek. If you go to this URL, the Ladybug team has a database of all different weather data, environmental, I forget P, weather data maps. So you can zoom in and you can see what data we have for the city of Toronto. The closest thing to Cherry Beach was the data being pulled from Billy Bishop Airport. I basically downloaded this file and can reference it. We may not even really fully need it for this session, but it's that, if you're wondering, that's where I pulled it from. Now, the rest of the file is broken up in an extremely didactic manner. What I mean by this is that it tells you step one, what am I exploring here? The core workflow is placing or packing with the layout of plants. Please read these. They are useful to reorient yourself. Definitely, I recommend starting with things here to gain knowledge, and then you can layer on complexity. So I'm going to start here and just talk about this. I will get to some more of these. I may not get to all of these, but you will get the idea that, hey, this one's about workflow, layouts, and patterns. This one is about planting things other than plants, like program or solar collectors. This one talks about making blocks. But in the same fashion that I made these as kind of modules, you can Frankenstein these as you see fit. And you will see that I tried to follow laying graphically out how these work by the same logic that the plant kit team gave up here. Creating an environment, an area, some plants. I tried to break it up into somewhat meaningful and graphically separated chunks. So let's go right up to the top. The very first thing we're going to do is we're going to make some topography. I need to make topography to put down my plants. Again, I'm using, in this case, I have my bifocals on so you can read. I also am turning on display selected only so that you can see things sequentially. So I'm going to turn, well, what I did is after drawing these features in Rhino, again, I don't have to draw these in Rhino. I could make them parametric inside of Grasshopper, like the way I did with Coco's file here. So here's Coco's file, Coco and Shushan's file. I have geometry, and I'm feeding it into other geo. This is the same process, the exact same process. Geometry that's drawn and parametrically controlled, feeding into add to geo set and making a topography. Same process. Geometry feeding into other geometry, which makes a mesh. Now that you know where this geometry comes from, I'm going to turn off topo layer. This is the reference geometry feeding into here, creating topo, drawing that topo, and making a final mesh. Now, the next thing I need to do is to make a plant environment. Remember, according to the process here, it is recommended that we create a plant environment. This is a database holder for where plants will go. It's kind of like a central brain component that governs where plants can and cannot go. So I'm going to make this next. If I were to create environment, I'll just pull this down here. It says three things. Tell me what your boundary is or boundaries. Tell me the cell size. In other words, how big of an environment should I be considering? And tell me the topography that the environment will go on. So kind of straightforward here. For my environment, it's basically the extents rather. For my environment layer, I actually made it a little bit bigger than the zone that I actually was modeling. I don't know if this matters that much, but the LandKit team did seem to make a point that it is somewhat beneficial to make the environment boundaries a little bigger. So here I've gone and drawn an environment layer in Rhino just to be like, here is a little bit bigger than what I want. The cell size, I've left it at 1 meter. If I hover over this, you can see that the default is 1.524 meters. I don't know where that number comes from. It's specific to the LandKit team. And for topography, I'm just giving it the mesh. I'm like, I made a mesh in TopoKit. I got a final mesh. It's the more triangulated form. That's okay. That's fine. And I'm giving it to the environment here. So now that you know how we made a simple environment, no sun, no slope, no elevation, it's just a raw form of an environment, I then need to define my planting area. So again, if we go to the slide deck, I've made my environment, giving it a mesh and a boundary. And now I need to make an area that takes the environment into account. So let's go ahead here. If I'm making under the Create subribbon tab, Create Planting Area, it says, tell me what the geometry is, where you want to put the plants, and give me E. So this one's also pretty easy. The geometry in this case, you can see here that I've basically taken the curves from these, we'll call them hill or topographic features in this plaza. And I've basically used that as the features that I want. So they're under the design layer. You can see them here. It's a curve that helped define these little hill features. These hill features were made using Subtab. Sorry, I'm getting a buzz. Never mind. A buzz. Oh boy. Some curves here. Sorry. The brain's a little short-circuiting. So here is those curves because I want to put plants on top of these hill features. That's my desire. That's my design intent. So again, I've referenced those curves in as set multiple curves. It feeds my geometry, and my E comes from the E of the environment. Pretty easy. Now, the next thing is I want to define plants. I want to be able to get some plant information or create plant information, maybe add niches, but ultimately I just want to lay those plants out onto the area that I said. So let's take a look at that. You can do a whole bunch of ways of pulling in plants. My honest recommendation is, I'm just going to get rid of this. I don't really need that. just do this. So this is in, actually, I'm going to save this as file B. I don't want to lose that feature. This now looks exactly the same way as O1 does. That little code snippet, that was the small piece that I mentioned. So to get plants, there's all kinds. There is some simple plants called pseudo plant parameters. You'll see in some of the videos that the LandKit team that they make some simple plants. It's effectively dummy plants. Pseudo plant parameters. Pseudo plant niche. These basically create some fake plants. They're not tied to species or anything. They just make some randomized plants. You're welcome to experiment with that too. But for the most of us, we want to work with real plants. So to get plants that have some real values, you want to use what's called the create plants from CSV data. So I could go to the data or sub-ribbon tab, go to the component called create plants from CSV. And it says, tell me where the CSV file is. Tell me if you want to change them by names or numbers, what the key field is to reference them, if you want to randomize anything, and if you want to query anything. Again, you can look at this in more detail, but the elements that matter the most is the CSV path. So for this, I'm just going to pull up a component called read file or file path. It looks like a hexagon. It's a data container. It contains information. And it has a little graphic that looks like perhaps your C drive / value here. It looks like a directory. So this is orange because it says, hey, I don't have any data. I'm a container of data, but I don't have data. Once you have data, you can plug that into here. And you can see again, because it's blank, I don't have any data. The file that matters for you is inside your FTP file. And I've made for you an example of objects and plants. Now, they are called the same thing, object, and you're like, what the hell is this? Why are there two of these? What this is one of them is made as an Excel file, and then I exported it as a .csv. Now, this is a great way to highlight the difference between the two. An Excel file, because it handles rich colors and specific formulas and interface, is usually about 3 to 10 times bigger than the raw data coming out of a .csv file. So here's the same file as an Excel sheet worth 10 kilobytes. It doesn't really matter, it's super minimal. But the CSV is minuscule. It is 1 kilobyte big. That's what Grasshopper likes. Grasshopper likes raw data, not super rich data. So you could point to this file by right-clicking on the file path and saying select one existing file, and just click on plant database example.csv. This will now pull in the data into CSV, and you have your list of plants pulled in from this file. This is what is inside the plant example. These were from, I made these fields of common name, origin, color, flowering. There are some that need to be there. So be super aware that if you're going to borrow this as a template, some of these need to be there. The ones that I would say you need is common name. I think there's actually a scientific name as well. Yeah, there it is. Maybe useful to keep common name, flower color, surprisingly, that you actually need that, height, feet, spread, sun exposure. Even if you have null files in here, it's okay. Those are the ones that you need. Everything else, bonus. Don't need any of this. So let me just highlight these here. You need a name, and the name should always usually be at the beginning. You need flower color. You need height and feet and spread. And I think you need sun exposure. These are the 5 that you need. I can talk about this in a lot more detail in class as to like why are some values as RGB and some as words. Why I keep height with feet. I can explain this. It's a bug inside of PlantKit. Kind of ironic to call it that, a bug inside of PlantKit. Spread both of these values because they're going into a metric file. Read this as metric values. Spread is the radius, either radius or diameter. I need to double check. But it's the size of it in plan. Height is how big the plant goes, and it will make a globular mesh object based on these 2 parameters. These are the 4 most important, and you do need color. I'm not exactly sure why, but you can have even a gray value if you want for something simple. I think it's because it has to color a mesh object downstream, but and sun exposure, you know what, maybe we don't even need this. I think I did one where it did not require it. These are the 4, a name, a color, and size and height. That's what you need. Okay. Once I have the data in, what I've done here in the sample file is I said, hey, when you're referring to the species, use the common name. Don't use the scientific name. It was just how I built the data, not how it needs to be done. It's how I did it. Now, if you wanted to take a look at what's coming out of the plant data, I have this tool here called Get Current Plant Data, which says, give me the list of plants from P, and I will tell you what's inside the attribute keys or the data keys. This may seem a little strange, but for each species, there are some key attributes. And then there are some additional data attributes. This is purely just to see what Grasshopper and PlantKit is reading from your CSV file. It's a good way to troubleshoot if things do not look the way they should. It's there just as a reference. What you actually care about is the fact that, hey, I got my plants, cool. Now I got my p-value, and I can put it into the area that I defined. Again, the area was these curves, and I can fill an area with plants that are constrained based on P, my plants, and A, my area. You can add additional things here like weights, packing ratio, if they are fixed, if they are constrained, if there is a buffer around them. There's lots of levels of control Remember in the PowerPoint when I was talking about circle packing, having a number of different parameters that create different effects? These are those effects: weights, ratio, fixed, constrained, buffer. And you can see that it's not a small, computationally lightweight component. It is a little heavy because it is doing something recursively, which means I do one thing and then I wait for that other thing to finish before doing another thing and another thing and another thing. Bin packing takes time. Bin packing, circle packing is maybe a better example. Here, no, that's not circle packing. Well, I guess it's sort of circle packing. This is maybe a better example of circle packing. You see how it needs to know that it finishes with one object first before doing another thing. This takes into account multiple steps and time. That's why it takes a long time to finish. This is also not circle packing, even though we say it is. This is a form of circle packing. It's just going super smooth. Probably another form of circle packing. Yeah, I'm not going to dwell on this too much. But that's why it takes time. A third of a second. Not a whole lot, but keep in mind, the more complex you make this, the more time it might take. When you're done filling an area with the plants, it's like, cool, okay, what happened? When you're done doing that, you're going to see that out of A, nothing happens. I'm clicking on this object, nothing is happening. Because remember that according to the process of plant kits, I need to lay out the plants and then I need to visualize them. All that's happening here is that it laid them out, but we can't see it. So what you need to then do is use the component called getPlantArea, which turns the value of A back into plants. And then you can take the draw component called getPlantInformation, and it will make for you, it will say, great, I have all the plants here, and I will lay them out for you. And you can see here that it took the plants that I made. I'm going to now turn my display off of this to lay these all out. Now I've done something here, which is I use the create material component from preview, create material, that says, give me the diffuse color of something, and I will make it a color, a material. And I turn that into my custom preview. So let me just turn this off and turn this on. And you can see now I have a series of plants which are based on this CSV file. So here's a good way to see this, perhaps. Scotch broom is, there we go. Scotch broom is my one of my few yellow plants. I think it's one of the few. Yeah, there's only a few yellow plants that I have here. There's a somewhat tall one, and there's a squatty one. So here's the somewhat tall one that goes from 2 to 5 meters. That is my honey mesquite, this taller one. And then the Scotch broom is the smaller one. So it's a graphic representation. It's not super precise. It's meant to be lightweight as possible because laying out plants can take a lot of time. And if you're wondering again, where the hell did he get these values for these plants? This came from Lands Design, my plant database. It will take a little bit of time to load this. 1 second. Here is Lands Design plant database. And if I knew a specific plant, like Scotch broom, that helps if I can spell Scotch broom. This is what Scotch broom looks like. These are some, I can double click it and see its properties. I can look at general species information that, hey, it's good for -23 Celsius values. I have some details about what its requirements are, some usage. I can read about its morphology, like is it a shrub? Is it a perennial? Is it deciduous? What is its maximum height? Color, flowering time, fructification color, characteristics like needs of water, resistance level to pollution, etc., how it's displayed, what it might look like if it's rendered using land design tool, which we will not, but that's where I got this value from. So this is super fast how you go from making a topography to making a plant environment to defining its area and to filling and visualizing the plants itself. So let's look at one more thing before I head off, before making another video. Maybe I'll have to split this video up. This sample set here looks at packing itself. So it may not be what you're looking for, but packing in a particular way is what's going on in the background. So what I'm going to do is turn this preview off. All that's done here is the same. I have a topo mesh here. You can see what it looks like. I've mated the environment, the plant areas by these edges. This is my area. I want to pack plants in, and I want to use some additional packing algorithm. So again, I would reference this same file. Plant database, CSV, okay. Don't worry about this stuff specifically. It may be needed. You can copy this to experiment. But let's take a look at what happened here. I again plant the areas with a constraints tool. This is this particular layout file. Fill area with plants constrained. It's just going to fill it, and I can add those parameters. When I'm done with A, I can augment or add more stuff to A by essentially here, as you can see, this is the tool called layout pack plants. And you can see this one takes even longer. It's doing the circle packing that we saw in some of these diagrams with more refinement. Okay, so that, I don't know, that's a little bit hard to visualize. Here's a good one. Here's a great one. Circle packing in Grasshopper of a fixed radius. So the radius is not changing, and then it's packing them together. And you can see that it does it over time. And so that element of time is what's being taken into account here with pack plants. So pack plant says, give me the area that I have filled. and I will try to pack it with a certain amount of steps, and I can adjust if I want to fix them. We can talk about that later, but what matters here is how many steps of time does it take to fill this area with its packing algorithm. So again, it's doing this, and it has this effect on the end, which is that it has made these plants pack in a particular way. So let me just actually go to wireframe, or maybe shaded is a little bit better. Yeah, okay. Yeah, maybe shaded is fine. So here's these plants, and it may look graphically no different than the first example. What matters is, let me just take that out. What matters is the fact that you can change this value here. So we can say, change the amount of time steps. And you can see here that it's packing them in more tightly as I go. It's trying, it's trying, it's trying, and it kind of stops around 55. It's really starting to slow down, actually, and take a lot of computation time. But this is how many steps is happening here to pack them in. Each time these circles graphically move in this little plan diagram thing on Pinterest here, that's what's going on in the background of the Rhino file. So if I click on my Rhino file, I tried taking it to 69 steps before it got really slow. And you can see that it packed it in a little differently. To show you the difference, let me bring down, I put little exclamation points here to, you would turn this on to see what's being created. But let me just pull this out here. You can see the difference. So this is unpacked and this is packed, okay? So let me display preview on. Here's the pre-pack and here's the pack. Look at that difference. Here they're much more spread out, and here they're really packed in. No packing, packing. No packing, packing. Same thing here. No packing or a little bit of filling versus packed. This is what's going on here. No packing, packed. But look at the hit you take on time. To pack them in that tightly, it took 1.6 seconds. So please take this into account. Every time Wallacey or Galapagos does something, it would add 1.6 seconds. So you may want to reduce the amount of steps here. Maybe something like 12 steps could be enough. It's much more lightweight. Unpacked, packed, unpacked, packed, unpacked, packed. Still getting good results, even with fewer steps to pack. It's much more efficient. Keep this in mind. Let's do one more element here. I'm going to turn this example off. Display. So here, I'm starting the same way. I have my geometry that's going in, making a mesh topography. Here's that mesh, not a big deal. I have my same environment from the curves, the reference curves. Sorry, the boundary curve here, and the cell size is the same. But now let's see something a little different. My environment is not just basic environment anymore. Now I want to add this chunk. And it's a fairly large chunk. It is adding sun exposure to the plant environment. I want to change this E to be something a little richer. And how I'm doing that is with this component called add sun exposure under analysis, add sun exposure to E. So you can see here, E says, give me your environment, which I could do from here. There's my, whoops, there's my environment. And it says, do you have anything other that would add a significant cast of shadow? What are your sun vectors, the lines that shoot out of the sun? What is the start of the growing season, the end of the growing season, and whether I need to convert hourly averages? What I've laid out for you here is basically a full version of this. Let's trace it back. E, easy enough, we did it. Other, I want some buildings to come in and affect this. I use the geometry pipeline. I don't have to use the geometry pipeline. I could just reference it in as mesh. You can see here that it's like pulling these buildings in as surfaces, and then it converts them to mesh. I do want a mesh because it's more lightweight, and I feed that result of meshes into other. Easy. Vectors. Vector says, tell me where the sun is at a particular time. And it is pulling them in from Ladybug. If I trace this back, I have a couple of relays here to keep things clean. The LandKit team made a little package that makes Ladybug stuff easy. Inside of here is some raw Ladybug stuff. Nothing complex, nothing crazy, but it is handy. It takes in location, latitude, longitude, a time zone, and a start time for, oh, this should say start. Sorry about that. Start time and last time. This is going from 1 or 0 to 11 or 12 for the months. The start of the growing season, and then it's the last month. So again, location name, Cherry Beach, Toronto. Latitude, longitude, I've already got those values for you. Time zone, which is, you have to give it a time zone so it knows how to calibrate itself against GMT. Start month, last month, and it makes for you a bunch of sun vectors. If you want to see those sun vectors, because it may be a little strange, you would have to actually pull some pieces out here to see what it looks like. Trust that it has them as a calculation. Now, for the start and end, pretty easy. I just pulled those over from the months. Here's my start month of March. I relayed it over, kept it clean for the start, and the end is November. So I'm done, and then conversion is true. And this just get me some more data. So now I give that data, it's a new E, and I've given that new E value to the area. Again, nothing too different. I've just have my area and I've made my environment a little richer. That's it. If you wanted to analyze what the sun looks like on this patch, this is optional here. It's not needed to affect the plants, but it helps you take a look at it. What it is making, I will turn the display special here. You can see what it's creating. It has made a series of point values that are either white. I'm going to turn this topo off. and turn this into wireframe. It has made some purple zones, which are partly shaded, black points, which are fully shaded, and white, which are fully in the sun. So you can use this just to reference it. You can just copy this itself. There's a lot going in here. I would just copy it. This is just showing you the data that is understood from here. And just to make things extra obvious, what I could do is open my context. Here's those buildings. And you can see as I move this building, the shade has now changed. I move the building, and the sun vectors from March to September are now calculated. This is assuming north. So the sun is coming this way. And it's making this impact on the area, the environment. This is just visualizing what is being calculated here. Okay. So now that that is done, great. I'm just going to hide away the context. Maybe I'll leave it in wireframe so we can see a little bit better. So now my environment is a little richer. I'm not changing my plants. I'm going to go back to just selecting the plants itself. Plant database, CSV. It will load. I'm pulling them by their common name. I am going to now consider the plant niche of sun exposure. When I calculated the sun, it was called sun exposure. Sun exposure needs to be called out here the same way, at least to my knowledge. So you give it P for plants, and you're saying, please give me plants. This is the niche data. Apply niche. If it has it in data, remember my plants do have, in this case here, they do have sun exposure for sun, part shade, and shade. This is the field that I want it to take into consideration. Sun exposure, that's why it's called this. And that's what I'm matching with this. I'm calling it the same, and I'm calling this the same. If I wanted to create this association, I need to make sure they're all called the same thing. Great. So now I have my niche taken into consideration. My environment is richer from the solar analysis, and I can pack my plants. I could just place them, but I decided to pack them. So now if I turn on my shaded view, these plants are going in this area. You can see not a lot of them are from my list. Not a lot of them are part shade. There's not a whole lot of them. There's a few, but my list is more preferential to sun. And you can see here in the shade, not many of them like the shade either. So the points that you're seeing, the purple, black, and white, remember, these are just a graphic representation of all the values that could be placed here. According to my environment prep, I could change this. Instead of being 1, I could make it 0.5, and you'll see more points probably pop up. Yep, there they are. It's just a sampling set. If I move a building around, You see now it has made deeper shadows over here, and less plants are going in that direction, or in this area, sorry. So I'm going to stop the video here for now and pass this along. I will go into more niches and restriction gradients and layouts and patterns other than objects and block creation in class. Steps 1 through 3 are the ones that matter the most right now for your consideration. Okay, thank you very much.